Hello everyone, my name is Shashank Sharma from AlmaBetter Full Stack Web Development course, and here I am to represent my all 5 DSA coding problems which I choose to explain in front of you. There are total 5 sectors. Co- First is code bug fixing, second is improvised perspective to the coding problems, third is logic building coding questions, fourth is analyzing traditional versus optimized approach, and the fifth one is incorporating best and worst scenarios in codes. Firstly, I log into my GitHub account, then I open the GitHub gist of provided by AlmaBetter. Then in this I choose top 5 problems and solve and then upload. The first question is from code bug fixing. Question first: the power of two puzzles. Sarah, a dedicated mathematician and puzzle enthusiast, stumbled upon an irritating challenge while delving into her research. She contemplated the creation of an is power of 2 function which takes a positive integer n as an argument and aims to disconcern whether the given number qualifies as a power of 2. In mathematician terms, an integer n is deemed a power of 2 if it can be represented as raised to an integer exponents. For example, 8 is a power of 2 because it can be written as 2 to the power 3. The provided code has an logical error in the return statement. We correct the logical error from logical OR to logical AND. The second question is from improvised perspective to the coding number. The question is chasing happiness through number. Alice loves playing with numbers and she recently came across a fascinating concept called happy numbers. A happy number starts with a positive integer and she wants to create an algorithm to determine if a given number is happy or not using the isHappy function. The isHappy function takes a positive integer n as an argument, return true if the number is happy and false otherwise. A number is considered happy if the process of summing the square of its eventually leads to 1. This process should repeat until the number either becomes 1 or get caught in an endless loop. We have given an approach and a hint to solve this. But approach to it said that rewrite the above code using set object. So in my approach, I use a set object named scene to keep track of the number encountered during the process. Then I iterate in a loop until either n becomes 1 or n is encountered again in the scene set. Inside the loop, we add the current n to the scene set before updating n to its sum of square of digits. After the loop, we check if n is equal to 1, which indicates that the number is happy, and return true. The question 3 is from logic building coding questions. The question is peak element. In the mysterious land of numbers, there lies a hidden peak element that stands tall and proud, surprising its neighbor digit. The inhabitants of this land, represented by a zero index integer array called nums, seek to uncover this majestic peak and bring forth its enigma to light. They have tasked you with the challenge. A peak element is an element that is strictly greater than its neighbor. Given a zero indexed integer, an array, along with the find peak element function, your goal is to find a peak element and return its index. If the array contains multiple peaks, you can return the index of any of the peaks. You may imagine that num minus 1 equals to nums n equals to minus infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You are required to implement find peak element function using an algorithm that runs 0 log n time. For this, to find a peak element in an array efficiently with a time complexity of O log n, we can utilize the binary search algorithm. In this, initialize two pointers left and right representing start and end indicates of the array. While left is less than right, do the following. First, calculate the middle index. Second, check if num's mid is greater than its neighbor. Third, if it is, then num's mid is a peak element, return mid. If not, update either left or right move towards the direction of higher neighbor. If the loop terminates without finding a peak element, return either left or right as both will point the same element. The fourth question is also from logic building coding questions. The question is, once upon a time in a vibrant land filled with the colorful objects, there existed an array called nums that held a collection of objects. Each object was uniquely colored red, white or blue, symbolizing different aspects of life. However, the array was in chaos with colors scattered randomly disrupting the harmony of land. The wise elders of land devised a plan to restore order and bring the balance to the array by utilizing the sort functions which takes an array nums as its argument. Give an array nums with an object colored red, white or blue and using the integers 0, 1 and 2 to represent the color red, white and blue respectively. For this, I choose the sort the colors in the array efficiently with a time complexity of on. We can utilize a three-pointer approach. In this, the first step is initialize three pointers red PTR, white PTR and blue PTR representing the position when the next red, white and blue element should be placed respectively. Then iterate through the array. If the current element is 0, search it with the element at red PTR position, then increment both red PTR and white PTR. If the current element is 1, just increment white PTR. If the current element is 2, search up with the element at blue PTR position, then decrement blue PTR. Continue the process until white PTR crosses the blue PTR. At the end, the array will be sorted with all zeros to the left, followed by all ones, and finally all twices. The fifth and the last question is also from logic building coding questions. The question is, once upon a time in the enchanting land of Numera, there existed a mystical array called nums. This array, unlike ordinary arrays, possessed a special property. It was sorted in non-decreasing order. Legend spoke of the powers hidden within this array, which could unveil the balance of positive and negative energies. Curiosity filled the heart of people as they wondered about the maximum force that could be harnessed. Deep in the realm of Numera, a brave adventurer named Alara set forth on a quest to discover the answer. Armed with a eye, a mystical algorithm, and the max count function, Alara embarked on a journey through the array. With each step, she encountered numbers that revealed the secret of their nature: positive, negative, or simply zero, a neutral force. As Alara transferred the array, she carefully used the max count function to tally the count of positive and negative integers, keeping track to their powers. Given an array nums sorted in non-decreasing order, return the result of max count function applied to the number of positive integer and the number of negative integer in the nums array. In other words, if the number of positive integer is pass and the num of negative integer is neg, then calculate max count positive, negative and the return the result. There is a note that 0 is either positive nor negative. For this, to find the maximum count of positive integer and minimum and negative integer In the given nums, we can use a simple algorithm that iterates through array while keeping track of the counts of positive and negative integers. Initialize variable max positive and max negative to store maximum count of positive integer and negative integer. Set both to 0 initially. Initialize variables positive count and negative count to 0 to keep track of counts of the positive and negative integer while iterating through array. Iterates through an array num if the current element is positive greater than 0, increment positive count and update